my name is Natalie Herview. I am one of the programmers with Links, and I work out of the University of Alberta under the supervision of Dr. Barbosa. And my main focus within the project is working with the technical side of the conversion process, and in particular the structured data sets that we want to convert into linked data, and then also trying to extract some of the extract linked data from natural language text. Today the talk is going to be really focused on the most structured data that we have, and one of the approaches that we're using to find the entities within it and link those entities to other project data sets and other authority files. And this talk kind of ties nicely into the last two because it really is utilizing a lot of the Kubernetes system stuff that Peter has wonderfully set up for us. And then it also is implemented as a module within Nessie. So it's really taking advantage of what Homa has set up as well. So I'm sure many of you already know this, but for students in the audience or anyone who doesn't, one of the big parts of Links is wanting to take all of these different data sets and connect them together and actually find new connections so that researchers can learn facts about their data sets and entities within their data sets that they didn't know about before. That involves both trying to find entities within a single data set and finding the matching entities or the equivalent entities within other data sets that we're all merging together within Links, but then also trying to find those same entities within like the larger linked over open data system, both so that researchers can move from their data sets into larger contexts, but also so that people within the linked open data community can start tying their data back towards Links as we develop it. And within Links itself, we have a lot of different types of data, and they're all going to take different approaches for this task of entity linking. Homa has already given a bit of an example for natural language text that we have and how you can find entities with that and find links for those. But we also have more structured data sets. So think of things like spreadsheets, and then also kind of the middle ground of semi-structured data. So things like XML or RDF data that has some schema, but isn't necessarily linked. And the data that we're seeing come in from Links, some of it is already had that step done, but a lot of it either doesn't have even links within the data set itself. So there might be duplicate entities within the same data set that don't have a connection, or they at least don't have any connection to external sources like things like Wikidata or BIAF that are really helpful as those consistent, constant identifiers for entities. And we have lots of different approaches, but one of the types of data that we're working with is really structured data. And so I'm going to talk today about the approach we've used for this really structured bibliographic data that we have, because it has some nice features that let us, we can kind of take advantage of it and have a bit of a more controlled method that can get us better probabilities and efficiencies, but does take a bit more knowledge of the data sets and configuration in the first place. And bibliographic data was a nice place to start with this because a lot of it was very structured, even if it varied a little bit in format, but it all had kind of predictable properties. So you could really compare, you know, the information about the work, the author, the publication, that kind of stuff is kind of consistent and predictable across data sets. And there are nice tools already that do similar things. So OpenRefine is one that you've probably all heard of. And it's excellent for data cleaning. It also gives you the chance to tie in some reconciliation services to try to link those entities. But we found when we were trying to work with bigger data sets that it wasn't always the best tool to use. It would often crash with large data sets. It could be a bit slow because you are really looking at every entity on an individual basis rather than a record level and kind of doing a Sparkle query for each entity. So it can be kind of slow. So we really wanted to try to, for this type of data, find a more efficient approach and kind of finding a probability score that we could hopefully understand better and use to do some automatic matching, because it's going to be a giant task to do manual vetting for all of these potential links, which we know will have to happen some, but hopefully not for all records. So I'm going to give you a quick overview of what this technique is, which is basically comes from the database management field, and it's called record linkage or data matching. There's lots of different names. So I'll give you kind of an overview of the general steps, but there's always different implementations. And then I'll get into the actual tools that we used to implement this as efficiently as we could. So the first step, which is very predictably data cleaning, right? And in particular for this method, it's really important to take what are common like compound data fields and to split them up into their own unique fields as much as possible, and to try to match those fields with whatever is in the authority file. We're working a lot with like VIAF and Wikidata, so we make sure that we're extracting data that matches, or we're cleaning our input data to match what is in Wikidata in terms of what fields are available for bibliographic data. So an example here is just kind of splitting the author name and the birth date and all of that so that you can do comparisons at a field specific level. And then we do some basic data cleaning. Some of this researchers will do in advance, but we also built some of that into the service. So things like lowercasing, removing punctuation, normalizing that way, lots of stuff like that, which is pretty typical in like natural language processing fields. And we really like the accuracy of the final system is going to depend a lot on the data cleaning steps that you do. So that's really important. So now if we have these two data sets, right, our authority data set and our input data set, we all of a sudden have every single entity within each data set that we want to compare to every other entity within the other data set, right? And that can turn into n-by-n comparisons, which I just given a quick example of 10,000 records in each data set is all of a sudden 100 million comparisons you have to make. So you can see with bibliographic data sets, you can imagine they're very large, and that can become completely overwhelming in terms of time complexity. So that's not feasible. So instead, the approach is to use a technique called blocking and generating a blocking key. So basically you're adding like another column to your data that is like a generalized version of some attributes of your field or of your record. So I've given one example here. So the blocking key could just be the first letter of the author's first name and then the first 3 letters of the author's last name. And your goal here is to create a blocking key so that you only compare records from your input data set that have that blocking key with records from your authority file that have the same blocking key. So you can see that can greatly reduce the number of comparisons you have to make, but there's some trade-offs here, right? So you can have a really tight blocking key that makes this a super efficient process, but you're going to completely miss potential matches and potential correct matches. If, say, I had misspelled the author's name, they might not even show up here, and then I'm not going to make the comparison. So you want to try to find a general enough blocking key. But you can also use techniques like using multiple blocking keys and doing this process more than once so that you still kind of balance that like recall where you're getting all the potential matches, but not making this a really long process for comparison. Okay, so we've done the data cleaning, and then we've done the blocking to try to figure out which records to compare to which records. And then we actually need to compare those records, right? And basically, this is where the benefit of that structured data is coming in. We're going to compare every like equivalent field within those records that we're deciding to compare to each other. And we use some sort of similarity measure for each one. And we can have a different one for each field. For things like strings, like names, people names, work titles, you can use string similarities like Jacquard similarity or Jarrow Winkler. For those unfamiliar, like a really basic version of a similarity metric would be like edit distance, which is just like a count of how many changes you would have to make to move from one string to the other. So you're just seeing how similar are these strings. It's kind of like fuzzy matching, right? For other fields, maybe like numerical ones, you could use buckets of decades or percent difference things. There's lots of different versions depending on what your data is. And you compute a similarity score for each of the fields. And then you would then need a way to actually combine those single similarity measures into one similarity measure for your entire record. And there's a lot of different algorithms that use that. The method that we're using, and you can look it up for more detail, is the Feleghi-Sunter model, but it's basically a probabilistic model that does unsupervised learning to determine what the overall probability of each record comparison is to be a match. And you get back like your value between 0 and 1, saying that whether it is likely to be not a match or likely to be a match. And then you need some way to decide which pairs to actually combine in your data set and add the URI into your input data. And there's different ways to do that. A really basic thing would just be thresholding. So like okay, anything above an 80% match, I'm going to trust is a good enough match. And then everything else, maybe do human vetting, something like that. There's also more sophisticated methods that involve like machine learning and actually trying to learn from past examples to see what kind of patterns would be likely to actually make it a perfect match or not. So then jumping into the actual tools that we're using. So there's a lot of different software packages you can use if you want to start testing out record linkage. This is a nice kind of technique to note as you're kind of moving into linked data. If you're just trying to deduplicate some of your data sets, or if you're starting to try to merge some of your data or even compare to authority files, it's something you can play around with on your own. But what some recent research has found that a lot of the common and really simple to get into record linkage tools, like in Python, R, there's more in other languages, the time complexity is exponential once you get into the data size of like a few thousand records, which again, we've mentioned, we wanted this to work for bulk data sets. So that wasn't going to be ideal. This paper was specifically proposing an R package called FastLink, and they showed a huge improvement, as you can see, for time complexity for processing, especially once they tried to use like parallel computing with multiple cores. And so what we ended up using was a open source package developed by the Ministry of Justice out of the United Kingdom, and they've used the same methodology as FastLink, but they've implemented it using Apache Spark, and that allows it to be really distributed and parallelized so that this can be more efficient. So for those who haven't heard of Apache Spark, it's basically a data processing engine targeted towards large-scale processing tasks, and it makes it quite simple for you to distribute your tasks and do parallel processing. So for example, with the methodology we've just described in this talk, each of those blocks that we've created for things that we want to compare every record within, each of those is sent to a different worker, like different Spark worker, and it can be processed separately, all at the same time, using different resources. When one block is done, because it had less comparisons perhaps, it can reallocate those resources to other workers. So that makes this a really nice tool to use. And we have also to really taken advantage of, as I mentioned, some of the tools we were already working with. So Apache Spark, it definitely takes some time. If you want to get into it, take some time to set up. You can do it locally on your own machine, though you're like definitely losing some of the advantage of having the like parallel computing, depending on your machine specs. But you can deploy it within like using Kubernetes or using AWS. There's lots of options. And I'm sure Peter can tell you how hard it was to set up. He kindly did that for us here. And once it is set up, using Splink was really simple to do. Once Spark was set up, it makes it quite simple to be able to basically just send a configuration file from the service that says, okay, here's the data, here's the code within S3 that we want you to run, and then the data within S3 as well. And then it handles the creating of the Spark workers, allocating all the resources, all of those steps, it handles that. And then we're also taking advantage of, I kind of mentioned S3, and then Nessie as well. So Nessie, we have it sending my service or this service, the messages using RabbitMQ. And then because this service is using Python, it's using the Pika RMQ client. And then all of the data is being stored in S3, as well as the code that's being used by the Spark operator. So it's really, once it's set up, it's a really nice connected system like that. And all of these tools are open source for you to use, but if this all sounds too complicated for this kind of deployed version, we'll also be having this as an available tool to the Links users and public so that you can use it to link your own data sets. And then just quickly, kind of next steps for us, even though this method is intended to be able to like hopefully find some better matches more quickly, you're never going to be able to find like perfectly certain matches. Especially, it's really important that we have a curated data set here, and we want to make sure things are accurate. So there will be human vetting needed. So hopefully by the next conference that we have, we'll be presenting about the interface that we're planning for vetting the results of this service, which our goal with that is really to try to speed up the bulk vetting process, which I know can be quite slow. So hopefully we'll have more on that soon. And that's all for me.